Put a cow and a wolf on the same cutting board, and suddenly one looks like dinner while the other looks like a crime scene. That is weird, because chemically speaking, both are made of muscle, fat, water, and protein. Humans have eaten cows, pigs, sheep, goats, deer, rabbits, chickens, basically an entire petting zoo with terrible job security. But lions, wolves, eagles, tigers? Almost never as normal food. And no, the answer is not just culture said so. Culture helped, but it arrived late. The deeper reason is that predator meat is a terrible deal long before it reaches your plate. Start with energy. A rough ecological rule says only about 10% of energy makes it from one level of a food chain to the next. Picture 100 units in plants becoming roughly 10 in herbivores, then about 1 in the predator above them. So if you want 1 pound of predator, you first need a much larger amount of prey to build that predator. And to build the prey, you need even more plants underneath it. This is why farming a lion for meat is basically farming meat to manufacture more expensive meat. You are feeding dinner to your dinner. A cow can turn grass and grain into beef. A lion turns antelope into lion, while spending huge amounts of energy breathing, moving, hunting, fighting, maintaining a giant body, and apparently refusing to become a cheeseburger at the end of the process. For an early human, the choice was even simpler. You could hunt the deer, or you could fight the thing that hunts the deer. One option is food. The other option is food, with knives attached to its face. So the first answer is economics written by ecology. Predators are expensive to produce and dangerous to acquire. But suppose you are rich, reckless, and deeply committed to opening the world's worst steakhouse. You raise the predator anyway. Now you hit problem number 2. Predators do not just sit at the top of the food chain. They collect what is below them. Toxins can enter near the bottom. Mercury in water, industrial chemicals, pollutants. A small organism absorbs a little. A fish eats many of those organisms. A bigger fish eats many of those fish. Then a top predator eats the bigger fish. The toxin does not politely reset to 0 at each level. It stacks. That process is called biomagnification, which is science's elegant way of saying, congratulations, everyone else's problem is now concentrated in you. This is why large predatory fish can carry significant mercury loads. The animal at the top is not just eating one meal. Over a lifetime, it is eating the chemical history of thousands of meals. That makes an apex predator less like a fresh ingredient and more like a biological archive, with teeth. And we have seen what that kind of concentration can do. DDT moved through aquatic food chains and accumulated in birds of prey. By the time it reached animals like bald eagles, the effects were severe enough to damage reproduction. The predator was not poisoned by one dramatic bite. It was poisoned by the entire menu below it. Now add another layer: parasites. Predators eat raw animals. They eat prey that may be old, sick, infected, or crawling with biological passengers nobody ordered. Bear meat is a famous example because of trichinella, a parasite that can live in muscle tissue. If infected meat is not cooked properly, the result can be extremely unpleasant for humans. And extremely unpleasant here does not mean you leave a bad restaurant review. It means larvae can end up in your muscles. At that point, the waiter is no longer getting a tip. So even when predator meat is edible, you often have to treat it more carefully. The food chain has effectively handed you a package labeled "Contains meat, may also contain consequences." Then there is the actual eating experience. Prey animals that humans domesticated were useful partly because they could be raised predictably, fed efficiently, and turned into meat on a large scale. Predators are built for a very different lifestyle. stalking, sprinting, fighting, competing. Some hunters who have eaten carnivores describe the meat as tougher, stronger, or gamier than familiar livestock, which is not an automatic deal-breaker. Humans have eaten plenty of weird things. We looked at an oyster, a wet rock full of mucus, and said, "Yes, appetizer." Taste alone has never stopped us. But taste matters when it joins the other problems. If an animal is dangerous to raise, expensive to feed, more likely to carry accumulated toxins or parasites, and the reward is meat many people do not even prefer, civilization starts doing some very basic accounting. And civilization is cheap. This is where the exceptions get interesting. Humans do eat some predators. Shark, alligator, bear in some regions. Squid and octopus are hunters. Predatory fish are common in many diets. So the real rule cannot be predators are poisonous. They are not. The better rule is that the higher, larger, longer-lived, and more expensive the predator becomes, the worse the trade tends to get. That is why the pattern is not a wall, it is a slope. A manageable predator may still end up on a plate. An apex predator is where all the disadvantages start forming a group project. And then culture walks in and makes the group project permanent. Across different societies, large predators often became symbols of danger, power, royalty, warfare, or the sacred. Lions became kings. Eagles became emblems. Wolves became spirits, monsters, ancestors, rivals. Once an animal is wearing a crown in your mythology, putting it between two slices of bread becomes socially complicated. Some religious dietary rules also draw explicit boundaries around birds of prey or animals that hunt with fangs and claws. Culture did not necessarily invent the avoidance from nothing. It could reinforce a pattern that already made practical sense. If an animal is costly, dangerous, risky, and rarely eaten, people do not build recipes around it. If people do not build recipes around it, it becomes unfamiliar. If it becomes unfamiliar, disgust gets stronger. And once disgust enters the chat, logic is finished. You do not need a spreadsheet explaining why wolf tartare is a poor life choice. Your brain has already closed the restaurant. That may be the most interesting part of the whole story. Humans did not sit down 10,000 years ago with a whiteboard and say, "Okay, team, trophic efficiency is bad, biomagnification is concerning, parasites are annoying, and lions keep biting Kevin." Nobody voted. The pattern emerged because the food chain kept making the same recommendation. Eat lower. Lower is cheaper. Lower is more abundant. Lower is easier to raise. Lower usually gives you fewer accumulated problems from everything underneath it. And over generations, practical choices harden into habits. Habits harden into cuisine, and cuisine hardens into the feeling that some animals are food, while others absolutely are not. So when you look at a cow and see dinner, but look at a wolf and see something that should not be near a fork, that reaction is not one single rule. It is ecology, chemistry, disease risk, economics, history, and culture all piling on to the same plate. Predators are not absent from our menus because their meat is magically forbidden. They are absent because, most of the time, they are nature's worst value meal. You can eat the animal that ate 10 other animals, or you can just eat one of the 10. Humanity looked at that equation, looked at the teeth, and made the surprisingly sensible choice. The wolf was never really competing with the cow. It was competing with the cow while also requiring several cows first. And that is a business model even humans thought was ridiculous.